All right, guys, welcome back. Algebra 2. Today we are doing section 3. All right, we are doing independent and dependent events. Still all about probability. Still very important. Key terms are important. Key concepts are important. Lots of word problems, all right? As I've said many times, key phrases are so important because they are guiding you through this problem. And if you're not paying attention to the phrases and the wording, then you will miss something in the problem. And if you miss that key thing, you may make the mistake about thinking it's this style, but it's this style, and everything goes wrong. All right. So all of that great positive words there, just to tell you that everything word wise is important. All right. Phrases mean something. So independent and dependent. Let's talk about what this means. So events, we'll zoom in here. Events are independent when you can have something that doesn't affect something else. Okay. And you can actually create independent events if you do something different after, let's say, the first event has happened. And what I mean by that is, let's say you are just pulling marbles out of a bag. Great. You pull a marble out of a bag, you see maybe a color or a number, then you put that marble right back in the bag, meaning now all of the original marbles are there. Meaning the next time that you put your hand in the bag, there still are the same quantity of marbles or colors or numbers, whatever it is. That means every event in that series is going to be independent, like independent of the event before it. Because you could pull out a red marble, look at it, put it back in. Every event after that is still the same. You could pull out a blue marble on the second time. Great. Now put that back in. Event for the number 3 turn, it's all still the same. Independent events means that every single time you are doing something, the total number of possible outcomes is all still the same. Nothing changed. You have the same chance every single time you pick because every event is independent of the event that just occurred before it. So that's independent. Now, dependent events right here, they will affect the probability of the next event. All right, so let's use that same one talking about marbles. You pull out a red marble from the bag, but you keep it out. Now, the total possible outcomes decreased by 1. Also, the total possible red marble number, that decreased by 1 because you pulled one out. So now you are affecting all of the other probability and chances and events later on because you kept it out. All right, there's another example problem the book gives you right there. Suppose there's 2 lemons, 1 lime. You pull out 2 pieces of fruit. The probability will change depending on the outcome of the first event. Just like the marble example I gave. If you pull out the fruit, you keep it out, every other event after that changes because you kept it out. So now all those odds are changing. All right, those are dependent events. All right, now for independent events, take a look at our equation here. Probability of event A simply multiplied by probability of event B. Nothing special about that because you have the same quantity and probability every time. It just depends on, like, okay, what are you going for? Maybe the red marbles, the blue marbles, whatever the color may be. All right, dependent event equation here. So probability of event A, that stays the same because that's the first event. You have the total largest chance on probability on the first try. But now this statement right here, the way you read that is basically probability of event B once event A has occurred. All right, and so usually that's going to mean that there is a decreased number in the total because you kept something out. All right, and it could also mean there's a decrease in that exact thing that you pulled out. So again, if we're going with marbles, you pull a red one out and you keep it out, your total number of marbles decreased, and then specifically the total number of red marbles decreased. All right, so maybe you have the same quantity of blue and white marbles, but the total overall did decrease because you kept one out. All right, and then one little definition I want to make sure you also get exposed to here. For dependent events, there's this thing called the conditional probability. So that means that event B is conditional because of event A. All right, so something happened in event A that will affect event B. That's called a conditional probability. So it's conditional upon, and then you fill in the blank of whatever occurred in event A. Independent events do not have conditional probability because every event is the same chance every single time. Okay, because it all basically it gets either erased or it starts over perfectly every single time. All right, I'm going to zoom down and leave this up there just for a second. This is a good example to copy down just because it gives you a really solid breakdown of when you are given like a table of values. And this is what we're talking about up here for a table of values. And then there's all kinds of different events. Could be dependent, could be independent. And these two example problems, they're separate from one another, A and B. I'd like you guys to look at this, read through it, and take the time to understand it. Okay, it's a good example. It's going to help you in your homework assignment. Could be useful on the test as well. All right, and I know I spoke about this in the last video, so I just decided to take a picture myself and put this on today's notes. So this is really good to have in your notes because this is if you roll 2 dice. This is every single possible outcome if you are rolling 2 dice. All right, so you got a red dice and a blue dice, 2 different dice. Remember that dice have 6 sides. This is every outcome. This is really helpful. It's easy to have in your notes. It's going to be very helpful. You're going to use it in today's notes, in today's homework. And you're going to keep using it also throughout the chapter. All right, let's get into some example problems. Okay, so speaking of rolling dice, here we go. The first problem here is rolling a 6 on one cube and a 6 on another cube. All right, let's think about this. Do we have an independent or a dependent event occurring? You roll 1 dice. What are the odds of getting a 6 on that 1 dice? Well, 1 out of 6. You roll another dice. Did that first dice affect how you rolled the second dice? It did not. So therefore, these are independent events. So that means we have the same probability of rolling a 6 on one dice as we do on the other dice. Therefore, we are just looking at a 1/36 chance of rolling a 6, then another one rolling another 6. So that is example problem number 1. Okay, let's take a look at number 2. Tossing heads, and then tails when tossing a coin 3 times. All right, now think about this. If you are tossing a coin, and this is just one coin, you flip a coin, what are the chances of getting a heads? 1/2. Now, when you pick that coin up and toss it again, is it affected at all by that first toss? It's not. So this is another independent event. So tossing heads, then tails. It's that simple. They're all independent. Coin only has 2 sides. So heads 1, tails 1. All of it's still 1/2. Multiply these together and get 1/8. All right. So these example problems are starting out pretty easy here. 2 independent events examples. All right. Let's take a look at our third example problem. All right. 2 number cubes are rolled. You have one black one, one red one. All right. Explain why the events are dependent and then find that probability. All right. So here's our statement. The red cube shows a number greater than 4 and the sum is greater than 9. So let's do a little explanation here. By the way, I have a note off to the side on my own paper. You're going to want to look at that chart. And when I say chart, I mean this chart right here. So you're going to want to look at that or take a screenshot of that or copy that, whatever it may be, because that's going to help you with this problem here. All right. So if we look, I'm going to write this down. All right. If we look at the last 2 rows, all right, that is where, let's see, red is 5 and 6, but only 5 of those combos make a sum that is greater than 9. So why is this dependent? Why is this not independent? It's dependent because you have a stipulation being put out there that says the red cube shows a number greater than 4. That has to be there. And then the sum is greater than 9. So that's why we'll zoom out to make sure you get that note there. So it's only going to happen within those last 2 rows. A greater number than 4, meaning it has to be 5, has to be 6. So if you roll the dice and you get a number that is less than 4, it changes all of the probability for the rest of the problem. So it does matter what you roll on that first cube. The red cube shows a number greater than 4, has to happen. Then roll the second one, and what is the sum that could be greater than 9? All right, so let's work out the probability here. For a red number that's greater than 4, we'll change our color. For a red number that's greater than 4, there are 12 possible outcomes out of a total of 36, which will reduce down to a 1/3 chance that you roll a number greater than 4. Okay, so that's the starting point here. Then, if you look at those last 2 rows, that's why I wrote this little note here. The last 2 rows are only creating those given perfect parameters where the red cube shows a number greater than 4 and the sum is greater than 9. Both of those parameters are met. So now we have a total of only 12 outcomes because the last 2 rows cover 12 total outcomes. But within those last 2 rows, how many meet the qualifications? 5 of those possible outcomes meet the qualifications of a number greater than 4 and the sum of the 2 dice is greater than 9. So this is dependent because we have to have both qualifications being met. A red that is greater than 4 and the sum is greater than 9. So the 1/3 now is multiplied by the 5/12, which equals 5/12. over 36. Okay, 5 over 36. And there we go. That's the probability. All right, dependent events, both qualifications have to be met. All right, let's finish this up here. Last example problems. All right, so you have a bag. We have 10 total beads, 2 black, 3 white, 5 red. All right, a bead is selected at random. We're going to determine whether the events first are independent or dependent, then find the probability. So let's do 4A right here. All right, we are selecting a white bead, replacing it, then selecting a red bead. This is independent because you are replacing it. So you pick a bead, see the color, put it back. That means the second time you're picking a bead, it's just like the first time. You're not changing any of the probabilities. So selecting a white bead is going to be a 3 out of 10 chance. And then it says replace it, select a red bead. That is going to now be a 5 out of 10 chance. Multiply those two together and then reduce, and you're going to get 3 over 20. All right, so I just went ahead and saved you the time, multiplied it, then also reduced it. Wanted to save on some space too. All right, so next one, 4B here. Selecting a white bead. So let's take a look at that. Selecting a white bead, not replacing it. So immediately we know that this is going to be a dependent because we're not replacing it. So the second time I pick a bead, all the chances are now changing because I kept a bead out. So we have a white bead, which is 3 out of 10 chance. Keep it out and then select a red bead. Well, we still have all 5 red, but our total number of beads dropped to 9 because we kept that first white bead out. So 3 out of 10 for the white bead, now 5 out of 9 for the red bead. Multiply that together, reduce it, and you're going to get 1 over 6 when you multiply that together and reduce it down. All right, last one here for C. All right, so this is selecting 3 non-red beads without replacement. So again, that means that every time you select a bead, it stays out. So that is going to create another dependent event because every time you keep a bead out, you're changing the odds for the next time you pick. So non-red beads means you pick either a black bead or a white bead. That's going to be a total of 5 because you have 2 black, 3 white. So 5 out of 10 to start, but then that drops down. That will drop down then to 4 out of 9 because I'm trying to pick another black or white bead. I had 5 to start. If I picked one, I'm now dropping to 4, but I also kept it out. So my total 10 dropped to 9. And then I do it one more time. So it's going to be 3 out of 8. And then multiply this out, reduce it down, and then we'll try to fit this in right over here on this side. That gives us 1/12 when you multiply it out and reduce it down. All right, guys, that covers us. Okay, that is all of the notes for today. Let's zoom out. So that is example problems 3 and 4 right there. And then example problems 1 and 2 right there. Okay, guys, bring your questions to class. Ask the questions. Focus, stay driven. All right, don't check out. I'll see you guys in the next one.